Yeah. So, Assalamu alaikum wa rahmatullahi wa barakatuh. So, I hope everyone is well and like enjoying. Okay, so without any wasting the time, let's see what was the thing that we are going to discuss. Okay, so yeah, as you know, like yesterday we discussed the arrays code and the linked list codes, and today is the time for like today and today's video also I have posted that video. In the earlier video we talked about the stacks, and now in this video we are going to see the queues. Okay, the queues codes and all. Okay, so let's dive in without wasting the time, because the video gets too long because the code is lengthy also. So first, let us visualize. Okay, like it will help me also, like what is actually a queue. Okay, so we all know that queue is like, see, in the like now only I had drawn the structure of the queue. Okay, and there was a problem, so I had to I was recording also, and then there was a problem, and then I like the video stopped and I deleted. So I'm just like doing undo, so we will just see that. Okay, so let's do it. So see, let's imagine they're like these are the persons. Okay, one, two, three, four. Let's say these are the persons, or you can say nodes. Okay, and this is a queue. You can say, yeah. So these are like one, two, three. These are four. Like we all know about the queue, like standing in a line in front of a in standing in line to get food from a restaurant, or from a, what to say, like to get tickets, train tickets, or bus tickets. Just like standing in a line where the structure is like this, where like this queue, it follows a particular structure, and that is like, see, the elements or the people get inside the line or the queue from one side, and then they get out from the other side. Okay, so that's the structure, you can say, for the queue, and the principle that is called the FIFO. Okay, first in, first out. Okay, so this is the structure that is called, not the structure, yeah, like, yeah, you can say a structure that is called the first in, first out. Okay, that follow the queue is a structure that follows this principle, first in, first out principle. Anything more? Okay, so that's only thing. One, okay, so two, three, four. So these are the four. These are like people, you can say, or nodes. Okay, so that's the visualization, you can say, for the queue. Now let's move back to the code. So yeah, I hope you all can see. Okay, so in the starting, we have included all like the file and the like the what to say, the file, or what it is called. Yeah, like modules and all. Okay, hashtag include IO stream, input and output stream, and the queue, and then the stacks to access their function, like their functionality and their their structures and all. And then starting with the scope, like the namespace scope. Okay, so that like we are using the namespace. It is not recommended in big programs, but for now it's okay. Then defining max queue, which is taken as 5, like wherever the max queue will be written, it will be like the compiler will replace it with 5. Okay, so that's like, okay, yeah, we all know that thing. First, let's start with a circular queue using an array. So we are first going to implement a circular queue. Okay, circular queue using an array. Sorry. So we are declaring the class circular queue, two private, then the private section, two variables. The first is the array, and then the first we are declaring an array, which is of maximum, like max queue size, that is 5, and then two variables more, front and rear. Like these are the variables that we will use to mark as the index. Okay, front index and the rear index of the queue, and then the public section of the circular queue class. This is the constructor, you can say. When we will define, like when we will make an instance of this class, then the front this front int will be like initialized with -1, and the rear will be initialized with -1. Okay, then function, yeah, like methods. Bool is full. So what we will return, like this function will check if the what to say, the queue is full or not. Okay, what it will do, it will like return rear plus one modulus max queue is equals to front. Okay, so that is return rear plus one modulus max queue. Okay, just wait a second, a phone call. Front or from the back? From the queue, the elements, I think they go from the, wait, uh, in queue, yeah, it is full, the queue is full, and then not empty, front is equals to 0. Okay, so I think the value get inside from the rear end. Okay, yeah, I think that's the thing. And they, wait, like z. Okay, yeah, like the from the front end the value comes out, and from the rear end the value gets in. Okay, and this is the rear end. And yeah, please, okay, so tolerate this drawing because I'm using the mouse and the laptop's pad. Okay, and the mouse pad where, so that's why the writing is like this kind. So yeah, let's say this is the first element, this is the second element, and this is the third element or the third node. Yeah. So what we are doing, what was the function that was to, yeah, checking the full. So if, what was it? Return rear plus one. Rear plus one. This is F, rear plus one. Then rear plus one. Okay, so if this is zero, this is one, this is two. So rear plus one is equals to three. Rear plus one is three. Okay, rear plus one, that is three. 0, 1, 2. 2 plus 1, that is 3. Modulus. Modulus, what was the modulus? Max Q, that is 5. Okay, right, yeah. Plus 5, no, max Q. Max Q, 5. Okay, so here more two elements will be there, then only. It's okay, because we have like maximum five spaces. Okay, so let's add those also, like one. Let's here add 0. Let's make also a compartment here. Too long. One, two, three, four, five. Okay, so you have got the what to say, five nodes, not nodes, um, five nodes in the area. Yeah, okay, five nodes in the area. So you have one, two, three, four, and five. So let's put a value here. Like let's put four. So this is zero. Then this will become one. This will become two. This will become three, and this is then four. So if four, so four plus one, then this will become five. If five modulus five equals to, if 5 modulus 5 is equals to front, and what is front? Front is 0. So 5 modulus 5 becomes 0. That is, yeah, it will become 0. 5 modulus 5 and the remainder is 0. So yeah, 0 is equals to 0. Then this will become true. That is we are at the end of the queue, that is we are in the full, we have like reached its limits. Okay, so now we have understood, now I have understood. Okay, yeah, yeah. So yeah, this is the function. As you can see, is full. This returns rear plus one, that is if we were in the last four. Okay, 4 plus 1, that is 5. 5 modulus 5 will become 0, and the front is also 0. So 0 is equals to 0, that is will return true. That is the queue is full. Okay, so that's the function. Then the empty, sorry for this. Yes. Yeah, then the is empty function. So what it will return if like bool is empty, when the queue will be empty, when the front is like not updated. Okay, so what we have kept front is equals to minus 1. So if return front is equals to true, that is if that is if front is minus 1, then will return true, and that is the bool is empty. Otherwise, if front is like 0 or 1, then that means bool is like the stack is not empty. Sorry, bool. The stack is not empty. Okay, then it will return false. So these are the two functions, full and empty. Then we have a function enqueue, that is to insert an element in the queue. So this takes a value, and again it checks what to say, a condition. Yeah, an if condition. If is full, that is if the queue is full, then see out queue overflow. We are trying to insert an element in a queue that is all like full. Yeah, queue overflow and return. Otherwise, if the queue is empty, then front is equals to 0. If the queue is empty, then yeah, the first element will be the front, that is front is equals to 0. Okay, first insertion. Otherwise, otherwise it will like if the queue is not empty, then we will go to this line. Okay, and here this line. What we are doing, that is the queue is now not empty. Okay, so we are doing rear is equals to rear plus 1. So rear means the last element that was, we are incrementing the rear so that we go to the next index. Rear is equals to rear plus 1 modulus max q. So we are doing modulus max q to to bound it between the limits. Okay, like 5. Yeah, so we have got to the next index, and then what we are doing, now we are using like that rear next index in that array and storing the value. So we have stored the value, and then we are printing that we have enqueued, and then we are printing the value that has been enqueued, that has been put in the queue, and then the end line. And then the next function in D is dequeue, that is popping out the elements from the queue. So again, we are checking the condition. If the queue is empty, again print out that we are going to delete something from a queue that is already empty. So it is queue underflow, and we are returning minus 1. And why? Okay, here we are returning nothing, and here we are returning minus 1. Why here we are returning nothing? Because in queue, because it's overflow, so we are not returning anything. But why not a number? Why shouldn't we? But then why we are returning a number here? Okay, because we are returning a number here because see, when the queue was empty, sorry, like old habit. Okay, when I was like recording for linked list, I was like in a habit of saying arrays. When I was recording for stacks, then I was in a in the like my habit was my habit became to say linked list, and when I'm recording the queue, my like the I've got the habit of stacks. So that's the thing. Okay, so see from where we have gone here. So see, when the constructor we are putting minus 1 in the front and the rear. Okay, so that's why we are returning minus 1 if the queue is empty, and nothing when the queue is full. So if the queue is not empty, then we are like, so what you're doing, we are deleting. Okay, so we are first getting the value that we are going to delete. Okay, so which value we are going to delete? So remember, this is a queue. So the elements are inserted from the rear end, okay, from the last rear end, and it is dequeued. That is, it is deleted from the front end. How the actual real life lines or the queues work, where we stand. Okay, like that. the front people like they get the tickets or get the food and they move on. Okay, they are dequeued, and the coming people come from the end. Okay, so that's the thing. So what you're doing, we are getting the front array front. Okay, so that value will be stored in the value. If front is equals to rear, if the front is equals to rear, that is means this was the last element because the front and the rear was same. So the front and the end were same. So this was the last element. Okay, what we are doing, we are making front and rear point to -1 because see here we had done the same thing initializing when the queue is empty. So place it put the value to -1. Otherwise, the queue is full. Like we have more elements. So just what to do? Like increment the front. Front is equals to front plus 1 and bound it with max queue. So like we will just increment the front and then return the value. So we have left that value. Like it will be staying in the queue, but we have left it. Okay, like the next time when the rear like after rotating, I hope like you can understand. Like I'm imagining like after rotating the rear will be also updated, and when the and this value that is like we have moved on will be also updated. So it's just like we have left the value. Okay, so that's the thing. So dequeue and now it has returned the value that has to be dequeued. So we have done the dequeue, and then the display function if is empty, if the queue is empty, print queue is empty. Otherwise, print circular queue contains and a variable is equals to int I, a temporary variable that is where we are storing the front. While true, like an infinite loop, see out like print the data of array or to see the stack first element in the second hour in the loop if I is equals to real until like if the I is equals to real, that is if the I and the real becomes equal, then break it. That means we have reached the last element of the queue. Okay, and then what you are doing, we are like okay, this condition is first, then we are incrementing and putting the bounds of the I is equals to I plus 1 modulus max q. Okay, so we have to remember this, that why we are putting this I is equals to rear in the in between before this, because see if we enter like if we move increment, like if we had incremented the I before checking it, then like we would have moved to the front, and we would have moved to the front pointer, and then again it was like we would have again copied the same element. Then wouldn't we have like I is equals to I plus 1? Like if I is equals to front break, we would have used that also. But at that time, the first element wouldn't have been printed, right? Because we are setting the I as front. Okay, so that's the thing. So now at the end, we are printing just a line. Okay, so that's the whole thing. Like this was okay. Okay, let me show you. This was all like implementing the queue using array. Now let's use the linked list. Okay, so from here we will see how we use linked list to make a queue. So first, yeah, let's make the node structure. Again, the node structure has a what's a data variable, and then a next pointer pointing to the next node, queue node. Okay, so that's the thing. And then a constructor with a value that will be passed as an argument, and the value will be like and value will be stored in the data, and the next pointer will be pointing to the null pointer and starting. Okay, then the class linked list queue. In the private section, we are like making a head and a rear pointer. Yeah, so queue node, that is a front node pointer. We are having two pointers. Okay, a front node pointer and a rear node pointer that will be pointing to a queue node, that is this type of data. Okay, so that's the thing. So we have got the two nodes, and in the public this is the constructor. Both the nodes will be like initialized with the null pointer, you can see. And then the function, the methods starting from here again is empty. We have to check if the queue is empty or not. Okay, is empty. How to check? Return front node is equals to null pointer. Okay, if the queue is empty, that means the pointer will be pointing to null. Okay, so that's the thing we are checking. If the front is null, then it's true and return that true. So is empty will become true. Yeah, and then the in enqueue. But where is the full function? Like is full or not? Okay, so we haven't. Okay, we don't have this. Okay, let's check here. The enqueue function. Again, we are entering a value. No, nothing to return from this function. Then like making a new node pointer and getting a new queue node, okay, from the dynamic memory, and then the value we are passing. If the queue is empty, then the front node will be pointing to the okay, front node will be pointing to the rear node, and the rear node, see, front node and the rear node will be both pointing to the new node because it is the only element or the node now, okay, and then we will return. Otherwise, there are elements or nodes in the queue. So what we will do? We have to make the queue circular queue, no, right? So we have to link all those things. So what we will do? We will make the rear node of the next. So of the next, rear node next. Okay, that is the last node's next point to the new node. Okay, last node's next point to the new node, and the rear node is equals to new node, and then the rear node will become the new node. The last node's next will be pointing to the new node. Okay, I've got this much. But what is the second line? And then the new nodes, if, and then the new node will become the rear node. That is that we are enqueuing the elements, enqueuing the elements in the last. Remember the queue principle. So what we are doing, we are making the last element point to the new node, and the new nodes, like the new node. See, we are making the last node, that is the rear node, next to point to the new node, and then we are making the rear node update. Okay, like we are updating the rear node to the new node so that it becomes the last. Okay, that's the thing. Should I show you in the visual? Okay, let's see it. So here only. Okay, let's on fast. Yeah, a bright color, bright color. Okay, see. Sorry, let's see. I made a stack. This is the queue. Okay, one, two, three, let's say. So what? From here, the elements will be go outside, and from here, the elements are coming in. So when we are enqueuing, that is inserting, what we are doing. Okay, so this is a linked list. So two is pointing to three, one is pointing to two, right or wrong? So and this is the front node. You can say this is the rear node that is pointing to now three. So what we are doing? We are making the rear node next pointer point to four, like point to the new node. So let's say this is the new node, okay, and we are putting the value here 4. Making the rear pointers next pointer point to new node, and the and then updating the rear to point to this new node. Okay, yeah, and then the rear is now pointing to this. So rear is updated from here to here, and then this is now pointing to this. So we have got the chain, okay, like this. Okay, 1, 2, 3, and 4. Okay, I hope you have understood it. Okay, so now let's head back to the code. What's next? Okay, then the dequeue function. Int dequeue. So this dequeue will be returning. This function will be returning a what to say? An int, yeah, a value that is which was stored in, like, which we are dequeuing, the element which we are dequeuing, that will be returned. So again, if empty, return -1. Otherwise, make a temporary pointer that will be pointing to the front node, because we are going to dequeue the elements from the front node because it's a queue. Okay, so int value is equals to temporary data. So the data that is in the temporary, that is the front node, will be stored in the value. and then the front node is made or is updated to point to the next front node next. Okay, if not front node, that is this was the last element, right? Yeah, if not front node, then make it to null. Why not -1? If not front node, rear node is equals to null pointer. Yeah, like same thing only, no, yeah, null, same thing, yeah. So if not front node, that is this was the last element, so make the rear pointer point to the null pointer. Okay, and then what will happen to the front is obviously pointing to the next, that is front's next was null, so front is pointing to the null. And if not front node, that is if not null, if not null if not front node, that is if front node is not there, that is if front node is null, then null and not will become true, so then it will go inside this, and rear node will become null. Okay, and that means the queue is empty. Otherwise the queue has, if this conditions like is what to say is if the condition is like if it is not there, if the condition doesn't meet, then yeah, like this is there the last two line to execute, that is delete the temp. Okay, so the temporary pointer will be deleted and the data will also be gone, and then return the value which you have stored in the variable, so return that value and just delete temp, that is free the memory up, yeah. And then the void display if is empty, that is again print that the queue is empty. Otherwise make a temporary node. Why this vs, make a temporary pointer that is pointing to the front node, out linked list queue, and while the temporary is there, print the temporary's data and update the temporary to the next pointer, so we are pointing from the front to the rear, yeah. And then print out cout null. Okay, and okay, that's the linked list implementation for the queue. And then the cross implementation, I think, yeah, implement stack using two queues, implementing stacks using two queues. Okay, so now the tricky things have come here. Oh my god. So these are the like the tricky things. Okay, and the tricky code. So now let's head back and get ready for oh, get ready for the what to say, get ready for the confusion. My hand is also like started to pain because of handing like catching the mic. Okay, like the headphone, the mic and on the headphone, I'm catching it and speaking there only. That's why. So okay, class stack using queues. So new class private queue. So here we are directly using the queue data structure from the library we just included on the top private section. Okay, queue int. So we have got two queues. So we are using two queues to implement like to make a stack, okay? And then the public section push, okay, function and the value that we have to push. Step one, push new item into Q2. So what we are doing, we are pushing the value into Q2, okay? So we have got two queues, okay. We have pushed the value into the Q2 first, okay? Then transfer all the items from Q1 to Q2. Okay, then we are transferring all the items until the Q1 is empty. We are transferring all the items from Q1 to Q2. Okay, Q1 dot pop, and at the same time popping all the elements from the Q1. Okay, now the Q1 is empty. At the last, swap Q1 and Q2. Now we are swapping the Q1 and Q2, and now we have like made what to say, like implemented a stack. Okay, wait, let me show you visually. Okay, so see where were we? So we have to implement a stack. This is a stack, okay? One, two, three. We have to implement a stack using queues. Okay, so let's what we have done. We have like made two queues. Okay, let's say this is Q1, Q2. What are the thing? Okay, the elements are will be coming from here. So this is the rear end and will be going out from here. Okay, front end again here. Then this will be going out here. Okay. So then what's next in the code? So we are first pushing the value into the Q2. Q2 dot push the new items into Q2. Push the new item into Q2. Let's say we have a item 1 in Q2. Okay. Remember, a stack is a last in first out structure. Okay, LIFO structure. So it's a LIFO structure. So the element that was inserted at the last will be the one first to get out. Okay. So that property we have to bring here. Okay, in the using the queues. Okay. So I have first pushed one into the queue. Okay. Then what's next? While Q1 is not empty. Okay. Q2 dot push. Q1 dot front. One dot pop. Okay, but Q1 is empty. So what we are doing, we are the loop will not occur like happen. And then at the last we are swapping Q1 with Q2. So the one will go here and it will come to Q1. Okay, so that was the thing. Okay, the next now again we are pushing two second, and one has been like gone from here. Okay, like one is not there now in Q2. So what happens to Q2 now? We have pushed the into Q2 while Q1 is not empty. So yeah, Q1 is not empty now. So what we are doing? Q2 dot push Q1 dot front. Q2 dot push into Q2. What is in the front of Q1? So what is in the front of Q1? Push that into Q2. Okay. What is in the front of Q1? Push that into Q2. So this one will be gone from here and it will be pushed to Q2. Okay. So we have pushed into Q2. Now Q1 pop, Q1 dot pop. Okay, so one is now popped from here. So now Q2 becomes 2, 1. Okay. And then swap Q1 with Q2. Swap Q1 with Q2. So Q1 becomes 2 and 1. So remember how we inserted this with these two numbers into the queue? We inserted first 1, then 2, right? Okay. And now see which element will be going out first. Which element will be going out first? 2, because 2 is in the front of the queue. Okay. So see, we have got the stack property. See, we have first inserted one, then the second, and the last element that was inserted will be the first to go out. So we have got the structure, right? You like the two was last inserted, and the two will be first one to go out. So LIFO, last in, first out, the principle we have got in. Okay, so this was the you can say the property that uh, that that was like of the stack, and we used it to make the stack from the queues. Okay, so now let's head back to that push function. Okay, so this was all in the function. So in the last we are just swapping the q1 with q2, and the property is made. Okay, so okay, and the next is the pop function, the deleting function. What if the q1 is empty? Return -1. Okay, because it is empty. Otherwise end value is equals to q1 dot pop, one dot front. Remember, we are implementing stack. So remember which element was which element was to be popped from the q1. It was in the front. Okay, remember the q1 was at the last. The q1 was the one which was populated, and the q2 was empty. Okay, remember when we swapped this. So What we are doing, we are popping the front of the Q1 and we will get the 2. Okay, remember that, yeah, that visual which I showed you. Okay, so we have got the 2 and we like it is working like a stack, and then we are just popping that that what to say, that data or that node. We are popping that data or the node from the Q1 queue, yeah, and then return that value. Okay, then int top. So what is this? This is used to just like peek, you can say like what is in the top. Okay, so if q1 dot empty return -1, again it is not there. Otherwise q1 dot front, what is in the top of q1, just return that. Okay, and then next implement the queue using two stacks. So now we are just reversing it. Now we are implementing a queue using two stacks. Okay, so yeah, the same thing, declaring a class queue using stacks, private. Okay, private section, we are like using the stack data structure, inbuilt data structure from the stack library. And then we are like uh, what to say, two instance or objects, two stacks. Okay, two stack objects S1 and S2 we are declaring here. And then the public section, like the first the enqueue method or the enqueue function, there we are putting a value. And then what we are doing, we are just pushing it in the S1, that is the first stack. So whatever value that we are given to NQ, we are just pushing in the S1 stack. Okay, and then for the DQ, so what does Q does? Q is a FIFO structure, first in, first out. So the first element that goes in will be the first element to come out, to be popped out, okay, to be dequeued. Okay, so yeah, remembering that. So what we are doing here is the implementation of this. If S1 dot empty, if the S1 is empty and S2 is empty, return -1. That is, there is nothing. If the both the stacks are empty. Otherwise, transfer the elements to S2 only when S2 is completely empty. So what we are doing, we are transferring the elements to S2. Okay, we are transferring the elements to S2 only when the S2 is completely empty. If S2 is empty, while S1 is not empty, okay, while S1 is not empty, push all the elements from the S1. Okay, this line, push all the elements from the S1, that is S1 top, to S2, and then pop each of them. Like after pushing, pop them. And if the S2 is empty, like if the S2 is empty, then int value, like make a variable, declare a variable, and store the top of the S2 into that value, okay, to that val variable. And then what we will do? And then pop the S2. Okay, so we have popped it, and then return the value. Okay, so now okay, so it's confusing in the code. Now let's see in the structure. Okay, yes, on. See, here is the, let's build up with something brighter. So what we are doing, we are implementing a queue. What is a queue? The first element to go in will be the first to go out. See, for first in, first out. Let's say one is the was the first to go in, then two was the, and then three was the last. So three will be last to go out. So now we have two stacks. Okay, stack one, stack two. Yeah. So let's name them stack one, then the stack two. So what we are doing, if both the stacks are empty, then one, okay, let's give a value in one of the stack, like transfer the elements to S2 only when S2 is completely empty. If S2 is empty, while S1 is not empty, so when we enqueue, we are pushing in the S1 value. Okay, so let's put some value in the S1 value. Let's put here 1, 2. Okay, 1, 2 are like, okay, for two things are good to check. So now let's go into the dequeue function. If S1 is or S2 is empty, no, it's not empty. If S2 is empty, okay, S2 is empty here, okay. If the S2 is empty, while S1 is not empty, push all the like push the top element S1 into S2, okay, and then pop it. So 2 will be going from here to here. 2 is gone here, and then we have popped it from here. Okay, popped it. Then again 1 will be gone to here, I think. Yeah, and then 1 will come here, and 1 will be popped. Okay, right? Yeah, it is in the loop. So yeah, it will be popped until the S1 is empty. Okay, so now S1 is empty, nothing is there. So now the loop will stop, and then we will go in the next. And then what is the value? What is the thing we are going to do? So okay, if we imagine that this was a queue, okay, just let me erase one thing. Let's remove this three because we have taken the examples of 1, 2 only. Okay, so yeah, if let's say this was a queue, okay, so you have to implement this queue. We have to implement this using these two. Okay, using these two. So what is the behavior of this? Like we have post 1 and then 2. So what was the first thing to go out? 1. So we had 1 and 2 in the stack, but what was going the first? 2 was going. Now we have converted it into this. Now 1 has came here. Now if we pop anything from S2, the thing that will be pop is 1. Okay, so let's see. Okay, int value is equal to S2 dot top. Okay, so this becomes the value now. This is the value. This is the value VAL. This is the value. Okay, 1 is the value now. So now what we are doing? We are popping the S2 dot top. Okay, what is in the top of S2? That is we are popping, that is 1 has been popped out and it has become the value now. And then S2 dot pop, that is now we have taken the value 1 into the variable, and now we have to pop, just pop 1 out, and then we have dequeued the one, that is this one came out, and then 2 is left, and then here also 2 is left, and here also 2 is left. Okay, so like we have found like how the using two stacks we have made the behavior of a queue. Okay, and in the last, like it will again be checked, like if is a, in the starting, if like again we want to dequeue, then if S1 is empty or S2, no, S1 is not empty, no, sorry, S2 is not empty. If S2 empty, okay, no, S2 is not empty, so it will not go into the condition. And then what we will do, we will just pop this 2 value out, so we have again the value becomes 2. Okay, the value variable becomes the 2 is stored in the value, and then it is popped out. So 2 is then popped out, and then it is removed and it is returned. So 2 is also gone out, and here also 2 goes out at the last. So that's the thing. And now let's head back to the code. Okay, it was like good for understanding using the visualization. Okay, so I've got it. So now the next, reversing a queue using a stack. Reversing, reverse a queue using a stack. Again, something dangerous. Not dangerous. Okay, let's see. Let's tackle this also. Okay, avoid reverse queue function. What it is taking an alias or a reference to the queue. Okay, reverse a queue using a stack. Okay, stack S. Okay, so we have declared a stack S. While the queue is not empty, S dot push the queue front the S. Okay, queue dot pop it from the queue. And while S is not empty, while S, that is the stack, is not empty, queue dot push S dot top. Okay, push the queue into, like push the stack elements in the queue and then pop all of them. Okay, so this is easy. Okay, wait, let me show you. I've got the visual like ready. So yeah, wait, just let me show you this. Here to show here. Okay, see what we are doing. We are reversing a queue using a stack. So let's see, this is a queue. Let's imagine this is a queue. One, two, let's take three also this time. Okay, so we have a queue. Now we have declared a stack here. We are now storing. Okay, so remember, elements come from here, goes out from here, pops from here. Okay, so now one comes here. We have to remember, we first like why we first check in the while condition that while the queue is not empty. So queue is not empty, so we just what we are doing, we are pushing the queue front to, like we are taking all the elements from queue and pushing it into the stack and then popping it. So one come here and it is popped from here, two comes here and then it is popped from here, three comes here and then it is popped from here. Okay, now remember how the elements from the stack, like what to say, how the elements from the stack goes out from here only and enters from here only. So now in the next while, what we are doing, we are checking that if the S is not empty, that is no S is not empty, then what we are doing, we are just popping, like taking all the elements from the top of the stack and pushing it into the queue and then popping it out. So yeah, three, push it into the queue. Okay, so first the three entered. And see, the three is now pushed into the queue. Three has come, pop it out. Then two is done. Okay, two has come, pop it out. And then one has also came, pop it out. So from the queue was first one, two, three, and see now it has reversed. Okay, now it has reversed using what? Using a stack. Okay, so that's the thing. Now let's move back to the code. Yeah. So we have done all the things. And the last, I think, is it last? Yeah, it's last. What is the time now? Okay, it's now late. We have to do it fast. So this is the last, the deck. You can say deck, double-ended queue using W linked list. So okay, deck using W linked list. Okay, so here in this, like here we are making a D node double, like you can say D node double node, or yeah, like this only. It has a data, what to say, a data part where the data will be stored, and then the two pointers, the previous pointer and the next pointer, that will be pointing to the D node only, D node data type, and then the constructor, the value will be the data will be initialized with the value. The previous pointer will be set to null, and then the next will be also set to null. Okay, and then declaring a class, like yeah, making a class deque. Oh, sorry, not this deque. It is deck, double-ended queue. Yeah, class deck private. So we are making a private section. Okay, two pointers, front and rear. It is for the deck, like deck. Okay, double-ended queue, not for the D node, double link list. Okay, so that's why it is for the front and rear is for the uh, deck. Okay, a double-ended queue, not for the list, doubly linked list. Okay, then in the public section, dequeue initializer, front is set to null and rear is also set to null. Then the is empty, again the function to check if it is empty or not. Return front is equals to null. Okay, we have set the front as null in the constructor. So if the front is null, then yeah, the queue, the deck is empty, that is double net queue is empty. Otherwise, insert at the front, a function to insert at the front. See, double-ended queue can insert elements at the front, can insert and delete elements from the front and the rear also. That is the positive thing you can say of the double-ended queue. Okay, so insert at the front end is taking a value. Okay, and then we are like making a new node, a new node pointer that way which will be pointing to a new D node with a value. Okay, and that value will be like parsed from here only. Okay, if is empty, again this function is used if the deck is empty, then front will be pointing to the rear. Okay, the front will be pointing to the rear. Okay, yeah, the front pointer will be pointing to the rear and the rear will be pointing to the new node. That is, both the front and the rear node will be pointing to new node. Otherwise, what to do? Make the new nodes where we have to inserting, okay, inserting in the front. So make the new nodes next pointer point to the front, okay, and the front's previous pointer point to the new node, okay, and then update the front. New node will be new node's address will be pointed to the front, okay. So let me just show you the visual. Okay, so see, double-ended queue. Okay, so yeah, how it is double-ended queue, like deck. Let's take this. Let's take this as the nodes. Okay, like the nodes which we are talking about. For now, let's take two nodes. Okay, this is pointing to this, and this is the null. This is also pointing to null. Here is what. Let's put here one, two. So what we have done, we have made a new node of value. Let's say put zero. So what we are doing first, this was the front, this was rear. So we are the new nodes next. What let's see. We are making the new nodes next. New nodes next pointer point to the front. Front's previous pointer point to the new node. Okay. And then front will become the new node. So this front is now updated to the new node. So now this gets attached. Okay, becomes this, and then a double connection is made here. Okay, so now the node is inserted. Okay, enqueued. Yeah, started the front. So now let's head back to the code. There's the code. Yeah, then insert at the rear end. Okay, so inserting at the rear end, same. Take a value. Yeah, like a pointer new node. Get a new d node. Okay, and then the value if it is empty, if the what to say, if the deck was empty, then yeah, front and the rear will be pointing to the new node only because it is the only node. Otherwise otherwise we are inserting at the rear, so make the rear next point to the new node, okay, and the new nodes previous point to the rear, okay, new nodes, and then update the rear to the new node, okay. So I hope like it's easy to show you, right? Wait, let me show you again. Like it is easy to see again. So see here again, this is the rear end. We are trying to insert an element here. Let's say 3 is the data. So what we are doing, this is the new node now. We are making the rear node next pointer point to the new node, right? Rear node's next pointer point to the new node, and the new node's previous pointer point to the point to the rear node, and then update the rear to the new node. So that now the connection has become, and then the rear is also updated. So yeah, and then let's move fast to the next function. Insert at the rear, so we have done this, right? And then delete at the front. Now the deletion function, delete at the front. If empty, return -1, okay. Otherwise, again temporary node, temporary pointer which will be pointing to the front. No, temporary pointer that will be storing the same address of the front. That is, yeah, pointing to the front. Okay, so we are deleting at the front. Okay, int value. So how to get the value? Temporary data. Okay, we have got the value. Then make the update the front. Front is equals to front next, and then if front is equals to front next. That is, we have updated the front. Now we are checking if the front is there or not. Like if it is not, if this was not the last node. Okay, so if front is there, that means there were element, like there are more nodes elements, okay. So what we are doing, front previous is equals to null pointer, okay. So yeah, we are making the front previous point to null, not to the thing that we are going to delete, okay. So okay, Otherwise, if the front is not there, that means this was the last. So make the rear pointer point to the null. Okay. But what happens to the front? If front is there, if front is not there, that is front has become null. That's why it's not there. Okay, so we have got the front also null. And then we are just deleting the pointer that it was pointing to, and then clearing the memory up, and then returning the value that we have stored in the variable. Okay. So I will be showing these two like in the same time. Okay, like when we'll go into the what to say into the display. Okay, that's when I will be showing. So first let's tackle this also in delete where if the deck is empty, return -1. Otherwise, yeah, a temporary pointer pointing to the rear that will be pointing to where the rear is pointing a value. How to get the value? Temporary is data. Okay, then make the array update the rear. So rear is equal to rear's previous. Okay, yeah, rear is equal to rear's previous. If rear is not there, that means if rear is not there, that means this was the last element, right? So rear's next. If the rear is not there, that means the previous is null. If rear is not there, that means rear next equals to null. Rear previous is not there, that means it is null. Okay, then rear's next is null. Okay, then we are setting if we didn't have set the rear next to null, then what would have been there? Like it was only like going to have null only, right? Because see, if it is pointing to the rear end, and rear will be obviously pointing to the null pointer. Okay, so just like a safety check. Okay, so yeah, just making the null rear's next point to the null. Otherwise, if rear is not there, that means it was the last element. If rear was null, if rear is null, that means that was the last element. So what we are doing? We are making the front as null pointer. In wait, I'm having a confusion here. If rear, that means if rear is there. Okay, if rear is there, that means if rear is there, rear is the rear's previous. Okay, if rear is there, that means rear. That means there are elements in the deck now also after updating the rear. That means the rear is now the previous one. So now like there are elements. So what we are doing? We are making the rear next point to null pointer. That means we are making the previous element point to the null instead of pointing to the current pointing to the rear that was it. Okay. Instead of pointing to the rear that it was earlier pointing. Okay, the element which we are going to delete. So this previous rear is pointing to the element which we are going to delete. So, okay, so so instead of pointing to that, we are making it point to the null. And if the rear is not there, that means it was the last element. So we are just what to say updating the front to point to null. Okay, but where the front is pointing. Okay, so yeah. So front earlier it was pointing to rear, but now we are going to delete rear. Okay, so yeah, now we should make the front point to null because we this is the last element and we are going to delete it. Okay, so you have got the thing, and then the delete the temporary variable and return the variable. Okay, so let me just show you in the visuals. So yeah, we have here. Okay, yeah, let's use a different color. Which color do you want to choose? Okay, I'm gonna choose you. Wait, let's make a queue first. It was like crazy, big, dark. Let's imagine a queue, imagination, then a node. Make the nodes, double-ended queue, okay. So now, so if you want to delete this one, okay, the from the front. So what we are going to do? This is the front. First, we are making a temporary variable, okay, that is made to point to the front node. And then what we are doing, we are make updating the front, right? Let me check it. Temporary, yeah, that is pointing to the delete the rear end, delete front, yeah. Yeah, first we are temporary pointer that is pointing to the null. Then we are creating to the value. Okay, so yeah, let's see 0, 1, 2. So this is the value that we are going to delete. So we are getting the value 0 here. And then front is equals to front next. So we are updating front from here to here. So now front is removed from here. Okay, front becomes this. Front is now pointing to this. So now we have what we have to do. We have to like if front's previous is equals to null pointer. If front is there, that means we are having element. What we have to do, we have to make the front previous pointer, right? Yeah. So what you have to do, you have to make the front's previous pointer point to null, okay? Not to this element because this is the node that we are going to delete. If we are going to point at this, then it's like you not like it's it is not good, okay? So we have to make it point to null, okay? And then just delete the temporary, okay? And the same thing for the rear end deletion from the rear end, okay? So yeah. See, now deleting from the rear end. Okay, just see. See this is the rear. Okay, see this is now this will be pointing to the two. Okay, so now you have to delete two. So for that we are setting like the same temporary variable and then pointing it to the rear. Okay, then we are updating the rear to the one. Okay, so now the rear is pointing to one. Then now we are setting the rears next pointer to null so that it's not pointing to the node that we are going to delete it, okay, and then we have set it to the null and then we are deleting the temporary, okay. So now I think you have understood. Okay, so now the this queue has only one element, one here, and it is pointing to null, and here also it is pointing to null. Okay, so that's how like what's the logic of these two functions, okay. Yeah, like delete from the front and delete from the rear. And if like wait, let me show you that out because I can also clear the things. And if like deleting this, if we like delete from the front, okay, let's take the delete front, okay. If not empty, okay, not is empty, then deleted it, okay, temporary got here, okay, now temporary is pointing to this, okay, and we have got the data. Front is equals to fronts next, okay. So now front, this was front, okay, remember here, see. So front is this. Now what we have done, we have updated front to the front next. Now front is pointing to null. Now the condition will be there, okay, that front, we have gone to front next if front. Okay, remember the condition in the delete front function. If front, that is if front is there, then front's previous set to null pointer. But this time the front is not there. So what we have to do else? Make the rear pointer point to null. Okay. But now the rear was also pointing to this. Remember here you can see the rear is also pointing to one. Now what we have to do? We have to now the front is null, so the condition, the if in the code will not go, the compiler will not go into the if condition. It will just go outside, and there it has that it has the code that has like it is telling to set the rear to null. Okay, now we have to set the rear to null, so the rear is now pointing to null, and the front is also pointing to null. So now we have got like a good execution. Otherwise, the rear was pointing to this node only, which was going to be deleted. So now I think you have understood it, and it is same for the what to set delete from the back or okay the rear end. Like if the rear end is like null, then set the if the rear is if there is not null, that if the rear is null, that is rear is not there. That means it was the last node, then set the front pointer to null. Then yeah, same, set the front pointer to null and then delete that. Okay, otherwise the front pointer would have been pointing to the node that was going to be deleted. I hope like I made myself and also you all like make it understand it, because see, a little bit confusion I am also having, but yeah, that's okay. Now the display function. Okay, like first let's head back. Okay, now the display function. If empty, display deck is empty. Otherwise, temporary pointer front, then print this. While the temporary is there, that means it is not null. Print the data and then update the temporary to the next and till the end. Okay, and then at the last print the null. So this is the display function. Okay, what is the time? Okay, so we don't have time, so we have to do fast. So now this is the main function again in choice, where we have to enter the choice circular queue, an instance of the circular queue, and then the linked list queue, and then the dequeue. Do see out like all the things like that will be printed into the console. You can say yes, the circular array, queue operations, linked list queue operations, test stack using two queues, reverse a queue using stack and all deck. Okay, and then zero for the exit. These are the switch. The choice is in the switch, and then the case one, two, three, four. Okay, and the five, you all can read this also, like pushing into the queue, then starting at the front and deleting, and then the case zero for exiting the program. Okay, to do all these things until while while the choice is not is equals to zero. Okay, while the choice is not is equals to zero, do all these things, and when the choice is zero, break the loop, return zero, and the program will end. Okay, just let me show you and run the program. Okay, come on. It's not stack, it's queue.cv. Let's see it. Yeah, okay, it compiled. There's no error. Dot slash a. Okay, so we have got the thing. Let's select the choice circular array queue operations. Okay. See, all the operations have shown here. NQ10, NQ20, NQ30. So the queue is not 10, 20, 30. TQ10. So the queue becomes, remember, starting FIFO, first in, first out. So 10 was the first to in and then the first to go out. Okay. Then let's try the second. What's the second? Linked list queue operation. So this is the linked list operation. You can see, okay, rear end and the front end and all. Let's try the third. Test stack using two queues. Test stack using two queues. Okay. Three stack top, three stack pop, three stack top now, two. What was that? Let me check it. Stack three stack top, three stack top now, two. Okay, one, two, three, it was there. So yeah, I also don't know. Okay, what was the thing that happened? I will be like checking. I have to check. Okay, but like later we can check. Oh, so where the stack? For the third, right? Case three stack. Okay, see, we are pushing one to three. Okay, in the stack. So what gets in stack top was three. Okay, the three leaf hole last in first out. Stack pop three was popped out, and the two is left. Okay, so that's the correct. And then let's try the sixth deck double, like the double-ended queue operations. Okay, null. Okay, five pointing to null. Okay, then null, another five, five to 10, and then 10, 10, 20, 20, 20. Okay, 20 is pointing to null. Delete the front. Okay, five is deleted. Delete the rear 20. Okay, deck is now having only 10 elements. Okay, so now let's exit the program. Okay, so we have exited the program also. Let's head back to the MS Word. Yeah, okay. So that's all for today, and like it was a long video. Okay, so thank you for listening to me, and Jazakallah khair, and enjoy learning, and enjoy learning and enjoy your life. Be healthy, learn, and help others and all. Okay, so thank you for listening, and Assalamu alaikum wa rahmatullahi wa barakatuh.